This program is rated G. It is suitable for all audiences.
Hey! Group 12.
Combination and different types of distributions.
Looks so good yet so intrigued. Applying everyday the props and statistics. We can learn a lot out from this unit. It may be difficult but the learning's so lit. Looks so good yet so intrigued. Applying everyday the props and statistics. We can learn a lot out from this unit. It may be difficult but the learning's so lit. Statistics and probability. Statistics and probability. I know sometimes it can be so hard. Learning those a lot of different formulas, but it's very useful in our daily lives. Don't you worry cause it's not a waste of our time. It's like puzzle pieces so hard to assemble, yet always get ready anytime for rumble. After brain is what we need for us to solve, oh yeah. After brain is what we need for us to solve, oh yeah. Statistics and probability. Hey. Good day, future educators. This is Rachel Maytanete, and I am your host for today's show. In this video, we'll fill your minds with everything about Anova. Yours truly will discuss about the one-way Anova, and the other topics will be brought to you by my fellow members, Tadle, Sister, and Turehas. So sit back, relax, enjoy, and hopefully you'll learn a lot out from this show. This is our show, this is our style, and this is the Innovative Show! Before we proceed in our lesson proper, let me present to you the learning objectives for today's show. So at the end of this discussion, 85% of the students are expected to use the one-way Anova technique to determine if there is a significant difference among three or more means. Then second, determine which means differ using the Schaff or Triquet test if the null hypothesis is rejected in the Anova. And lastly, use the two-way Anova technique to determine if there is a significant difference in the main effects or interaction. Now, brace yourselves for we're about to learn the chapter 12 entitled Analysis of Variance or Anova. We've learned from chapter 9 that F-test can be used to compare two variances. And for everyone's information in connection with our topic today, F-test can also be used to compare three or more means. And that technique is called analysis of variance or Anova. So, what is Anova? Anova is a statistical test used to test claims involving three or more means with the use of F-test. Again, what is F-test? As I've mentioned earlier, it is used to compare two or more variances. It can only show whether a difference exists among three means, but it cannot reveal where the difference lies. It is just used to clarify whether the claim should be accepted or rejected based on the results of the data which you have gathered. If ever, the F-test indicates that there is a difference among the means, other statistical tests are used to find where the difference exists. The most commonly used tests are the Shaft test and Chicay test. And this will be discussed in this video by my co-members. There are two classifications of the Anova test. We have the one-way Anova and the two-way Anova. The analysis of variance that is used to compare three or more means containing only one variable is called one-way Anova. One-way Anova is used to test hypotheses concerning the means of three or more populations. Let's say, for example, suppose a researcher wishes to see whether the means of the time it takes three groups of students to solve a computer problem using Fortran, Basic, and Pascal are different. In this example, the researcher can use the one-way Anova technique for this test, since it is concerning the mean of the three groups obtained from a single variable. And it is the type of computer language. And this computer language are the Fortran, Basic, and Pascal. Nagets ra ba ang example? Kay di ba ana raman ta mo gamit og one-way Anova if the means of the groups are obtained from a single variable. Kay di ba by the definition of the one-way Anova, it is a statistical test used to test three or more means or comparing three or more means from a single variable or from only one variable. So sa atong example kay nga atong variable ato kay ang computer languages man. Unsa ang mga computer languages kay katong Fortran, Basic, and Pascal. So, there are three assumptions for the F-test for comparing three or more means. The first one is the population from which the samples were obtained must be normally or approximately normally distributed. When we say normally distributed, diba, it is in a bell-shaped curve and the mean, median, and mode are equal and are located at the center of the distribution. Familiar naman tayo no? And the second assumption is the samples must be independent of one another. Meaning, pag independent samples, diba, the occurrence of the samples should not affect the occurrence of one another. There is no relationship among them and can stand and appear without being affected by the other samples. And the third and last assumption is the variances of the populations must be equal for us to come up with the correct conclusion as we test the data. Even though you are comparing three or more means with the use of F-test, variances are used in the test instead of means. Why? Kay diba, analysis of variance gani ang Anova. So, variances matters. If naabay significant difference ang mga groups or wala. And we can solve for variance without the help of the means. Naji? Now, I'll discuss first the formulas that we'll be using for the one-way Anova test. Para ma-apply nato siya later sa mga examples when we go along with the solving time. There are two different estimates of the population variance with the use of F-test. We have the between group variance and the within group variance. Between group variance involves finding variances of the means. It has a notation of S squared capital B. And the formula for between group variance is S squared B is equal to summation of n subscript I times the quantity of bar x subscript I minus bar x gm to the power of 2 over k minus 1. Within group variance is made by computing the variances using all the data and is not affected by the differences in the means. It has a notation of S squared capital W, and the formula of S squared W is equals to summation of the quantity n subscript I minus 1 times S squared subscript I over summation of the quantity n subscript I minus 1. So, sa hypothesis na ta, for the test of difference among three or more means, the following hypotheses are to be used. We have the null hypothesis or HO. Mu sub 1 is equal to mu sub 2 and is equal to mu sub 3. All of the means are equal. Kaya diba sa null hypothesis, it always predicts a no effect or no relationship among the means. And for our alternative hypothesis or H1, at least one mean is different from the others. Kaya diba ang alternative hypothesis always states the existence of difference among the means or among the parameters. The degrees of freedom for this F-test are DFN and DFD. DFN is the degrees of freedom for the numerator, which has a formula of k minus 1, where k is the number of groups. And the DFD, or the degrees of freedom for the denominator, has a formula of n minus 1, where n is the sum of sample sizes of the groups. Sample sizes need not to be equal, and the F-test to compare the means is always right-tailed. So, positive siya kanunay ha. If ever man-negative gani siya, there is a problem of your competitions. We have in here the summary table for the analysis of variance. In the table, we have SS sub B, which stands for the sum of squares between groups. SS sub W is the sum of squares within groups. K is the number of groups. N is the sum of the sample sizes for the groups. MS sub B is the mean square between. It has a formula of MS sub B is equals to SS sub B over K minus 1. MS sub W is the mean square within and has a formula of MS sub W is equals to SS sub W over N minus 1, and lastly, the F value with a formula of MS sub B over MS sub W. And, diba in math, di dyan ta makasabot if puro ra discussion or puro ra yaw-yaw. We need to solve examples to fully understand the topic. So, it's solving time. Are you all guys ready? So, here's the example. A researcher wishes to try 3 different techniques to lower the blood pressure of the individuals diagnosed with high blood pressure. The subjects are randomly assigned to the 3 groups. The first group takes medication, the second group exercises, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded. At the level of significance with 0.05, tests the claim that there is no difference among the means. The data that are collected are shown in here. So, diba, ang need naman nato is S squared B and S squared W para makasolve ta sa F value. Kaya mo man yung formula, diba? But before we arrive with those corresponding values, we need to undergo first a series of steps. steps or a step-by-step process para makuha nato ang values nila for us to solve the f value. So, katong pasabot na ko nga step-by-step process, familiar naman jud ta ana, di ba? Kay kanang mga step 1, step 2, step 3, chucho, kay nga naman kanunay nga atong mga activities and lessons lately. So, as usual, step 1 is state the hypothesis and identify the claim. In our problem, we were asked to test the claim that there is no difference among the means. Therefore, this will be our null hypothesis kay no difference man daw. So, null ang atoang claim. That is, HO is mu sub 1 is equals to mu sub 2 is equals to mu sub 3. We assume that all the means are equal, no difference. Thus, for our alternative hypothesis, we'll assume that H1 is at least one mean is different from the others. Now, shall we accept or reject the null hypothesis? Well, we will find it out. Now, sa step 2 na ta. Step 2 is find the critical value. So, in finding the critical value, we need the DFN and the DFD. Since K is equals to 3 groups man diba ang given sa problem, we have medication, exercise, and special diet. We can now solve for the degrees of freedom for the numerator with a formula of k minus 1, and that is 3 minus 1 is equals to 2. Now, for our degrees of freedom for the denominator, our n is equals to 15. So, n minus k, that is 15 minus 3 is equals to 12. We'll use these two values to look for our critical value in the table H with an alpha of 0.05. And as we locate these values, we could see that 3.89 is the critical value obtained from the table. So, kindly check lang no sa inyong mga table H sa F table if sakto ba jud. If ever nag-doubt mo nga tinuod ba ang 3.89 ang critical value. So, step 3 na ta. In step 3, compute the test value. Test value is what we need for us to arrive with the values of SS sub B and SS sub W. Medyo taas-taas dyan siya nga process mga mads, so please bear with me. In step 3A, it is finding the mean and variance of each sample. In here, given na daan ang means and variances, diba? We have 11.8 as the mean and 5.7 as the variance of the first group. 3.8 is the mean and 10.2 is the variance of the second group. And lastly, 7.6 is the mean and 10.3 is the variance of the third group. So we can see man sad ani no. If you wanna check if it's true kay base nagjawa-jama lang kog gawit ani ba ta sayop di ay ko, you can solve with me man sad. You can use your calculators. You know naman sa the formulas for the mean and variances, diba? For step 3B, find the grand mean. Grand mean is the mean of all values in the samples. It is denoted by bar x gm with a formula of summation of x over n. So, in our problem, naa naman tayo data, so i-substitute na lang nato igo. We have 10 plus 12 plus 9 plus 15 plus 13 plus 6 plus 8 plus 3 plus 0 plus 2 plus 5 plus 9 plus 12 plus 8 plus 4 over 15 as our n. We have a grand mean of 116 over 15, that is 7.73. For our step 3C, we need to find the between group variance. Katubit ang S squared sub B. So as we can see, that's the formula for between group variance, no? So i-substitute tara nato siya igo. 5 times the quantity of 11.8 minus 7.73 squared plus 5 times the quantity of 3.8 8 minus 7.73 squared plus 5 times the quantity of 7.6 minus 7.73 squared over 3 minus 1. That is 160.13 over 2. We have a between group variance of 80.07. Then for the step 3D, within group variance na sad ang atong kuhaon, that is S squared sub W. So again, substitute ratas iyang formula. That is the quantity of 5 minus 1 times 5.7 plus the quantity of 5 minus 1 times 10.2 plus the quantity of 5 minus 1 times 10.3 over the quantity of 5 minus 1 plus the quantity of 5 minus 1 plus the quantity of 5 minus 1. That is 104.80 over 12. Now, we have 8.73 as our within group variance. So, at last, nakita na jud nato ang values ni S squared sub B og S squared sub W, which is what we need to solve for the F-test value. So, sa kataas sa process, no, worth it man sa nga atong pag-solve kay nakuha na jud nato ang values nga needed to solve for the F-test value. So, sa step 3E na ta, solve for the F-test value. So, substitute ra nato ang atong na-solve nga values ni between group variance, which is 80.07 over the within group variance, that is 8.73. So, with the use of our calculators at home, we obtain 9.17, and that is our F-test value. So indeed, the process is long, but then we had come up with the value of the F-test value. So now, sa step 4 na ta mga mads. In step 4, make the decision. This is the exciting part kay we'll know now whether i-reject ba nato or i-accept ang atong null hypothesis. So sa atong problem, the decision is to reject the null hypothesis. Why? Since 9.17 as the F-test is greater than the 3.89, which is our critical value. If we'll draw this one in a graph, makita jud nato clearly nga nasud siya sa critical region. This proves that at least one mean is different from the others. So again, reject the null hypothesis. That is the decision. Now, step 5 na jud ta mga mads. Now, in step 5, we need to summarize the results. So, there is enough evidence to reject the claim and conclude that at least one mean is different from the others. To clearly see the process, we will input our computed values using the analysis of variance summary table. Ang atong mga i-input na values can be seen in our computations on step 3 part C and D. So, for the sum of squares between groups, it is the numerator of the fraction obtained in step 3. On the part C, which has a value of 160.1335. For the sum of squares within groups, it is the numerator of the fraction obtained in step 3 part D, which has a value of 104.80. Then we will add all the sum of squares to get the total, which is 264.93. Then we will input the degrees of freedom for the numerator, which is 2, and the degrees of freedom for our denominator, which is 12. Then total it, 2 plus 12, we have 14. Then for the mean squares, the mean square of between is the between group variance, and that is 80.07, and for the mean square of within, that is the within group variance, we'll have 80.73. Then for the F-test value, we will just input the 9.17. This summarized table of results will serve as our enough evidence to clearly reject the claim and conclude that at least one mean is different from the others, as what I've always mentioned a while ago. So, na-solve rin na to ang given example, no? At this point, let me ask you if nakasabot rin ba mo, guys? Have you all understood when to use and how to solve for the one-way Anova test? Well, I bet you'll all say yes kay mga bright na mga classmates na ako, no? So without further ado, let me give you the floor to my co-members, Miss Tadle and Miss Sister, to tackle about the chef test and GK test. Classmates, take it away.
And now I will going to discuss about what is the use of the Skiffy test and the Chugi test in elementary statistics and probability. So the use of Shafi test and the Chugi test is when the null hypothesis is rejected using the F test. So the researcher may want to know where the difference among the means is. So ang gamit sa Shafi test o sa Chugi test is kung ang imong null hypothesis is ma-reject using the F test, so ganahan ang researcher nga makaibaw sila where the difference among the means is. So the Shafi test and the Chugi test are procedures to determine where the significant differences in the means lie after the Anova procedure has been performed. So ang Shafi test o ang Chugi test kuno is procedure sa para makadetermine ta nga aha ang significant differences sa means nga atong gi-kumpara after the Anova procedure has been performed. So the Shafi test rather and the Chugi test are different. So first, let's find out first what is the Shafi test. So in order to conduct the Shafi test, one must compare the means two at a time, using all possible combinations of mean. So for example, if there are three means, so the following comparison must be done through this illustration. So we have mean sub 1 versus mean sub 2, mean sub 1 versus mean sub 3, and the last is mean sub 2 versus mean sub 3. So kung natay tulo ka means sa atong data, so mao na yung combination nila. So first mean versus second mean, first mean versus third mean, second mean versus third mean kung natay tulo ka mean. So formula for the Shafi test. So this is the formula for the Shafi test. So we have f sub s is equal to quantity of mean sub I minus mean sub z squared over a squared sub w open bracket quantity of 1 over n sub I plus quantity 1 over n sub g close bracket. Next, so where mean sub I and mean sub z are the means of the sample being compared, and n sub I and n sub z are the respective sample sizes, and the within group variance is denoted by a squared sub w. So F value for the Shafi test. To find the critical value for the Shafi test denoted by this symbol F complement, so we will multiply the critical value for the F test by k minus 1. So there is a significant difference between the two means being compared when the value of f sub s is greater than the value of the f value for the Shafi test. So this is the So this is the formula for finding the F value for the Shafi test, which is the critical value. So F value for Shafi test is equal to quantity of K minus 1 times the critical value of F test. So let's take a look at this example. So like for example, about lowering blood pressure. So using the Shafi test each pair of means to see whether specific difference exists at A is equal to 0.001. So this is the given scenario. So a researcher wishes to try 3 different techniques to lower the blood pressure of individuals diagnosed with high blood pressure. So the subjects are randomly assigned to 3 groups. So the first group takes medication, the second group exercises, and the third group follows a special diet. So after 4 weeks, the reduction in each person's blood pressure is recorded. At A is equal to 0.05, tests the claim that there is no difference among the means. So this is the given data. So the first group, which is medication, so this is the given data, which are 10, 12, 9, 15, 13. So the mean for the first group is equal to 11.8. So the second group, which is exercise, so this is the given data for exercise. So we have 6, 8, 3, 0, 2. So the mean for the second group is equal to 3.8. And the third group, or the last group, is diet. So this is the given data for diet. So we have 5, 9, 12, 8, 4. So the mean for this group is equal to 7.6. So in this example, we have 3 groups. So 3 means rather. So natay tulo ka mean. So naman tayo tulo kami, so atong combination must be done through this illustration. Kaya naman tayo tulo kami. So atong combination is 3. So we have mean sub 1 versus mean sub 2. So manay first natin ang combination. Second combination, we have mean sub 1 versus mean sub 3. The third combination, we have mean sub 2 versus mean sub 3. So manay atong combination nila. So first, we need to find the F test using the Shafi test. For first combination, we have first mean versus second mean. So recall the formula for the Shafi test. So F sub is equal to quantity of X sub 1, which is may atong X sub 1, which is may atong compare ang X sub 1 of mean sub 1 versus mean sub 2. So mean sub 1 minus mean sub 2 squared over A squared sub W, open bracket, quantity of 1 over N sub 1 plus quantity 1 over N sub 2, close bracket. So substitute the values. So the mean for the first group we have 11.8 minus the mean for the second group, we have 3.8 squared over the value for within group variance, we have 8.73, and open bracket, quantity of 1 over 5 because there are 5 sample sizes in the given data, plus 1 over 5 gihapon kay may 5 ka sample size sa data. So ni equal siya og 18.33. So atong value sa F test sa first natong gi-compare, which is the first mean versus the second mean, is equal to 18.33. So proceed na sa ikaduha nga atong gi-compare, which is the second mean versus the third mean. So substitute. So mo gyapon the same as atong gibuhat sa pagkinahanglan. So follow the formula for the Shafi test. So we have F sub S is equal to quantity of mean sub 2, which is the second mean, minus mean sub 3, which is the third mean, squared over A squared sub W, open bracket, quantity of 1 over N sub 2 plus quantity of 1 over N sub 3, close brackets. To substitute the formula, so the value for the substitute the value rather. So the value for the min sub 2 is equal to 3.8 minus the value for the min sub 3 is equal to 7.6. So muna 3.8 minus 7.6 squared, and the value for the value for within group variance is equal to 8.73. Open bracket, quantity of 1 over 5 plus quantity of 1 over 5, so na-equal siya of 4.14. So sa ani, so ang F-test sa min sub 2 versus sa min sub 3 is equal to 4.14. So last we have min sub 1 versus min sub 3. So more pa tong baton. So the formula for the F test for the Shafi test is equal to F sub S is equal to quantity of min sub 1 minus min sub 3 squared over E squared sub W, open bracket, quantity of 1 over N sub 1 plus quantity of 1 over N sub 3, close brackets. To substitute the value, so the value for the min sub 1 is equal to 11.8 minus the value for the min sub 3, which is equal to 7.6, over the value for the within variance, which is denoted by E squared sub W, is equal to 8.73, open bracket, quantity of 1 over the value of N sub 1, which is 5 because there are 5 sample in the given data, plus 1 over 5, so na-equal siya of 5.05. So now, since K is equal to 3 because there are 3 groups, and N is equal to 15 because in every group it consists of 5 sample sizes, so 5 times 3 is equal to 15, so 15 ang total tanan, and A is equal to 0.05. So DFN is equal to K minus 1 is equal to 3 minus 1 is equal to 2. So K minus 1, so substitute the value for K, which is 3, so 3 minus 1 is equal to 2. So itong value sa DFN is equal to 2. And while the value for DFD is equal to N minus K is equal to substitute the value for N, which is 15, so 15 minus 3 is equal to 12. So that is the value for our DFD. So the critical value is 3.89 obtained from table H. So the critical value sa aning example is 3.89 obtained from table H. So now let's move on to find the F value for the Shafi test. So this is the formula to find the F value for the Shafi test, or the critical value for the Shafi test. So symbol is equal to K minus 1 times the critical value of F test. So remember, our critical value for F test is 3.88 obtained from table H. So F sub is equal to K minus 1 times the critical value. So K minus, the value for our K minus 1 is equal to 2 times the value for our critical value is equal to 3.89. So ang critical value, ang value sa atong ang F value for Shafi test in this example is equal to 7.78. So since only the F test value for part A, which is min sub 1 versus min sub 2, is greater than the critical value, which is 7.78, so the only significant difference is between min sub 1 and min sub 2, that is between medication and exercise. So since kuno ang if this value for part era is greater than sa atong critical value, which is 7.78, so ang pasabot ana ang mean sub 1 versus mean sub 2 ra mooy na ay significant difference nga between, so that is between medication and exercise. So ang pasabot ani between medication and exercise is maoray na ay significant difference sa given data. Kay kung ang f-test value is greater than pagali sa critical value for the Shopee test, so mora na ay significant difference nga sa mean sa duha ka mean nga imong gikumpara. So we're done with the Shopee test. So let's move on now to the second one, which is the tricky test. So the tricky test can also be used after the analysis of variance or the Anova has been completed to make pairwise comparisons between means when the groups have the same sample size. So the symbol for the test value in the tricky test is denoted by letter Q. So formula for the tricky test. So Q is equal to mean sub I minus mean sub J over square root of A squared sub W over N in rather where mean sub I and mean sub J are the means of the samples being compared, and N is the size of the sample, and the within group variance is A squared sub W. So let's take a look at this example. So example about lowering blood pressure. So this example is mura po ni siya gigamit example nga atong gigamit sa previous nga topic, which is the Shopee test. So using the tricky test, so test each pair of means to see whether specific differences exist at A is equal to 0.05. So kaning example is not ay tulo ka comparison. So first one, we have mean sub 1 versus mean sub 2. So we will find the Q value for this comparison. So Q is equal to mean sub I minus mean sub 2 over square root of A squared sub W over N. So we will gonna substitute the value. So the value for mean sub 1 is equal to 11.8 minus the value for mean sub 2 is equal to 3.8 over square root of the value for within group variance, which is denoted by A squared sub W, is equal to 8.73 over the value for N is equal to 5. So ni-equal siya 6.06. So ang Q value for the first comparison, which is mean sub 1 versus mean sub 2, is equal to 6.06. So let's move on to the second comparison, which is mean sub 1 versus mean sub 3. So we will gonna write the formula to find the Q value for this comparison. So Q is equal to mean sub 1 minus mean sub 3 over square root of A squared sub W over N. So substitute the value. So the value for mean sub 1 is equal to 11.8 minus the value for mean sub 3, which is equal to 7.6 over square root of the value for within group variance. We have 8.73 over the value for N, we have 5. So na-equal siya of 3.18. So the Q value for the second comparison, which is mean sub 1 versus mean sub 3, is equal to 3.18. So let's move on to the next. So the comparison for mean sub 2 versus mean sub 3. So write the formula. So Q is equal to mean sub 2 minus mean sub 3 over square root of within group variance over N. So substitute the value for mean sub 2, which is 3.8, minus the value for mean sub 3, which is equal to 7.6 over square root of the value for within variance which is 8.73 over the value for n, which is 5. So na-equal siya of negative 2.88. So the Q value for this comparison, which is min sub 2 versus min sub 3, is equal to negative 2.88. So nakakita naman tas kanang respective value sa nilang tulo sa tulo nga comparison. So we'll now proceed to the next one. So the next process is to find the critical value for the Tsuki test. So to find the critical value for the Tsuki test, we will use the table N. So the number of means denoted by letter key is found in the row at the top of the table, and the degrees of freedom for R found in the left column denoted by V. Since K is equal to 3, so ang K nata is equal to 3, and the atong degrees of freedom is equal to 12, and our A is equal to 0.05, so the critical value is 3.77 obtained from the table table N rather. So hence the only Q value that is greater in absolute value than the critical value is the one for the difference between min sub 1 and min sub 2. So the conclusion then is that there is a significant difference in means for medication and exercise. So pasabot anhi ang first na comparison, which is ang min sub 1 versus min sub 2, is moora may dakong Q value that is greater in absolute value rather than critical value. So ang min sub 1 and min sub 2, ag ilang Q value is dako pa sa critical value. So pasabot anha ang min sub 1 and min sub 1 versus min sub 2, so naadad to makita nga naa sila significant difference kay ang Q value nila is dako pa sa critical value. So we have min sub 1 and min sub 2 means for medication na og sa exercise. So naa di ay significant difference between medication and exercise kay ilang Q value mas dako pa sa critical value. So ang rules ani sa Tsuki test, kung ang imo galing Q value is mas dako pa sa critical value, so naa ako ni significant difference nga nahitabo sa duha ka means nga imong gikumpara. So kani nga result ni-agree ra po ni siya sa previous nga topic, which is the Shopee analysis. Kaya katong sa Shopee analysis is ang naara pa significant difference adto is between ra pod sa medication and exercise. So same ra sila resulta sa Tsuki test.
A cup in hand, you know it's worth your while. A cup in hand, can you just stay for a while? Let minutes turn to moments.
Ikaw, para kanino ka bumaba?
Let's sip, let's share. It all starts with a Nescafe.
So now let's go on to two-way analysis of variance or two-way Anova. Again, what is one-way Anova? There is only one independent variable. So while in two-way Anova, from the word itself two, so it involves two independent variables or what we call factors. So it is quite complicated since many aspects should be considered. So through this, the researcher is able to test the effects of two independent variables on one dependent variable. So in two-way Anova, there are two independent variables and one dependent variable. So therefore, we can test the interaction of the two variables. Nasabtan? Okay, now I will give you an example. So suppose a researcher wishes to test the effects of the two different types of plant food and two different types of soil on the growth of certain plants. So ang atong independent variables ani is ang type of plant food and type of soil. Ang dependent variables nato ani is the plant growth. So mao ni ang porma if i-group nato. So there are 4 groups. Ano man? So before that, so take note nga groups for such a two-way ANOVA are sometimes called treatment groups. So anong 4 groups man? So naay plant food 1 and soil type 1. Naay plant food 1 and soil type 2. Naay plant food 2 soil type 1 and plant food 2 soil type 2. That's why there are 4 groups. So this is 2 different treatments since each variables consist of 2 levels. So anong 2 levels man, di ba? Kaya naay plant food type 1 na apoy type 2 sa plant food. Then naasay type 1 sa soil, naasay type 2 sa soil. That's why it is called 2x2 design. 2x2 design. So we can also have 2x2 design, 2x3, 3x4, 4x3, 4x4, depends on the given. So now, sa atong hypothesis, so there will be 3 hypotheses. Nga naman, 1 for each independent variables. So pila man kabuok independent variables sa 2 ANOVA, so there are 2. So meaning, naanay duha ka hypothesis and 1 for dependent variables or 1 for the interaction. Nakuha? So all in all, there are 3 hypotheses. So these are the hypotheses of our given problem. So number 1, null hypothesis, there is no interaction effect between type of plant food used and type of soil used on plant growth. In alternative hypothesis, there is an interaction effect. So mao ni ang hypothesis sa interaction. So obvious. So number 2, null hypothesis, there is no difference in means of height of plant grown using different foods. In alternative hypothesis, there is a difference in means of height. So number 3, there is no difference in means of height of plant grown in different soil types. So in alternative hypothesis, there is a difference in means of height of plant grown. Kadong 2 and 3, mao to ang hypothesis sa independent variables. Nakuha? So there, all in all, there are 3 hypotheses. So next, so diba, same sa one-way ANOVA between group variance estimate and within group variance estimate are calculated. So an F-test is used for each of the independent variables and interaction. So here is the table. It shows the summary of the results of two-way ANOVA. So in the first column, we have here the source. So under it are the factors, interaction, and the error term. So the next column is the sum of squares. So ang under ani is ang basa ana is sum of squares for factor A, factor B. So same sa factor B, interaction, error term. So sum of squares for factor A, sum of squares for factor B, sum of squares for interaction, sum of squares for error term or within group. So for the third column is the degrees of freedom. So to get the degree of freedom for factor A, so A minus 1, where A is the number of levels of factor A. So, di ba sa problem, pila ka levels ang factor A, di ba? Duha. So same for B minus 1. B is the number of levels of factor B. So for the interaction, A minus 1 times B minus 1, and for the error, A times B times N minus 1. So remember, N is the number of subjects in each group. So for the fourth column, we have the mean squares. To find the mean square of factor A, mao ni ang formula. So mean square of factor A is equal to sum of square for factor A over A minus 1. So para mahinumduman, refer ta sa table. So kung sum of square for factor A over A minus 1, mana sa factor A. Diba? Then sunod, i-line lang siya, i-align. So sum of square for factor B over B minus 1. Then sum of square for interaction over A minus 1 times B minus 1. So tunong ra. Tangan ninyo slash para mailhan ninyo, mahinumduman ninyo. So mana siya. So yung na ra. Then, and for the F values, refer sa table para sa yun. Example sa F value for factor A, syempre ato sa mean square of factor A, then overan nimo sa mean square of error term, and so on and so forth. So every mean square i-carries nimo overan nimo sa mean square of error term. So yung anara siya nakuha. So wala pa tanahuman sa degrees of freedom na atay gitawag og numerator and denominator. So magkuha ta sa degrees of freedom numerator. So unsaon? So ngayon siya for factor A mo ni siya A minus 1. Sa denominator may man siya A times B times N minus 1. So remember, kaning A times B times N minus 1 mo ni kadong sa error term. So nga na siya pagkuha for factor B sa interaction. So we can also refer to table para masabtan kung isa gani ang value sa degree of freedom sa error term, maunay denominator for each factor. So magamit na siya in case for the critical value. So, mo ni ang numerator. So, ano siya. Then, and now for the assumptions. So, same ra sa one way. Ano bang assumptions sa two-way? Except sa sample size. So, naay nadugang sa two-way. Ano ba? Which is a group must be equal in sample size. So now, I will give you an example for you to understand more. So, we have here the steps. So, let's follow the 5 steps. So, step 1, state the hypothesis. Step 2, find the critical value for each test. Step 3, complete the summary table to get the test value. Step 4, make the decision. Step 5, and summarize the results. So for example, a researcher wishes to see whether the type of gasoline used and type of automobile driven have any effect on gasoline consumption. So ang independent variables na to ani are the type of gasoline and the type of automobile. Then, ang atong dependent variable is gasoline consumption. So, continue. 2 types of gasoline, regular and high octane, will be used. So, this is our factor A, ang gasoline, factor A. And it has 2 levels. Ang 2 levels ani ang regular o ang high octane. Nakuha? Then 2 types of automobiles, 2-wheel and 4-wheel drive. So, will be used in each group. So, mao ni ang atong factor B and it has also 2 levels. So, ang atong 2 levels ani ang 2-wheel and 4-wheel. Kuha? Then, so here is the given data and summary table. So, given na ang data and sum of squares. Now, let us have the solution. Step 1, state the hypothesis. So the hypothesis for the interaction, so muna siya, the null hypothesis, there is no interaction effect between type of gasoline used and type of automobile a person drives on gasoline consumption. Ang alternative hypothesis that there is an interaction effect between type of gasoline used and type of automobile a person drives on gasoline consumption. So moto siya ang hypothesis sa interaction. Ikaduhang hypothesis. So this hypothesis is for the gasoline types. So the null hypothesis, there is no difference between the means of gasoline consumption for two types of gasoline. Sa alternative, there is a difference between the means of gasoline consumption. So for the third hypothesis, this hypothesis is for the types of automobile driven. So the null hypothesis, there is no difference between the means of gasoline consumption for two-wheel drive and four-wheel drive automobiles. In alternative hypothesis, there is a difference. So all in all, there are three hypotheses na atong mo. For the step 2, let us find the critical values for each f-test. So since each factor has two levels, so ang atong design is 2 by 2. So in factor A, it has two levels. So diba remember, so ang A na to is equal to 2. And factor B also is equal, B is equal to 2 kay naasay 2 levels. Then, so the degrees of freedom for each factor are as follows. So ato nang kuhaon ang degrees of freedom for us to find the critical value. So just substitute, diba? Ang atong A is 2. So 2 minus 1 is equal to 1. So sa factor B, 2 minus 1 is equal to 1. Then sa interaction, 2 minus 1 times 2 minus 1 is equal to 1. And for the error term or within the group, 2 times 2 times 2 minus 1 is equal to 4. So nga naman, remember nga, N is the number of data values in each group. So pila man ka data values in each group. So diba na ay so mo na siyang 2 times 2 is equal to 4. Then 2 minus 1 is equal to 1. So 4 times 1 is equal to 4. Nakuha? So to find the critical value for the factor A using the significance level of 0.05, so the degree of freedom numerator, diba remember, is 1. So 1 man to ang factor A, diba remember? And the denominator is 4, diba kadung error, 4 man to, diba? So ato ni i-trace. So na to. So factor A is equal to na siya 7.71. Now let's find for the factor B. The same naman ang value, no? Diba sa kuan B is equal to 2, diba? Kay same ra pud sila nga 2 levels, nas like 2 levels. So same ra pud answer. So factor B is also 7.71. So for the interaction, same ra sad kay diba ang A o B same na 2 levels. So 2 minus 1, 2 times 2 minus 1 is equal to 1. Then denominator niya is 4, so mo nang 7.71 magyapon. So basin mingon mga ay same value ra din ni ang factor A, factor B, and interaction dili. It depends kung unsa ang given na ay possible sa akong given earlier. It could be 3 levels or 4 levels, 2 levels. So for example, ang factor A is na ay 3 levels and factor B is na ay 2 levels. So dili siya magkapareha. Diba? For the next step, the step 3, complete the Anova summary table to get the test values at we compute ang mean, square, o na. mean squares. So given na ang sum of squares, so let us substitute. So diba ang mean squares, so mean square of factor A is equal to sum of square for factor A over A minus 1. Substitute na nato, diba sa given is ang sum of square for factor A is 3.920 over 2 minus 1. So ang answer same maghapon kay 2 minus 1 equals 1. So 3.920 divided by 1 is equals to 3.920. So same, just substitute also for the mean square factor B. So makuha ra gyapon nimo same 9.680 for interaction. Substitute the formula. So ang answer is 54.080 for within error. So makuha na to, diba kay 3.300 over 4 is equal to 0.825. So now, since we have already the value of the mean squares, so now let's compute for the f values. So let's just substitute from the formula given. So for factor A, mean square of factor A over mean square of error term is pila ganito ang mean square sa factor A, diba? 3.920 and sa error term 0.825. So divide, ma-equal siya sa 4.752. So same sa factor B, so ang answer is 11.733 and sa interaction na ay 65.552. So to show it in a table, sumani ang forma. So now for step 4, make the decision. So since f value of factor B is equal to 11.733 and f value of interaction is 65.552, so they are greater than the critical value, which is 7.71. So the null hypothesis concerning the type of automobile driven and the interaction effect should be rejected, since the interaction effect is statistically significant. No decision should be made about the automobile type without further investigation. So that is the decision. For the step 5, summarize the result. So since the null hypothesis for the interaction effect was rejected, it can be concluded that the combination of type of gasoline and type of automobiles thus affect gasoline consumption. Now, ang atong main effect is the effect of the type of gasoline and the effect of the type of automobile driven. So if there is no significant interaction effect, the main effects can be interpreted independently. If there is a significant interaction effect, the main effects must be interpreted cautiously. Nakuha? Now, to interpret the result of a two-way Anova, so the researcher suggests drawing a graph, plotting the means of each group, analyzing the graph, and interpreting the result. So, example based sa atong gasoline consumption. So, yung ano siya, for plotting the means of each group. So, we will solve for the means and then drawing a graph, yung ano siya, forma. Yan na. Then, in analyzing and interpreting the graph, na atay gitawag diri og disordinal interaction o ordinal interaction. So these are the two types of interaction. So ang disordinal interaction is when such an intersection occurs and the interaction is significant. So do not interpret the main effects without considering the interaction effect. Nakuha? So remember nga ang this ordinal if mag-intersect gani. So na ay intersection. And then the interaction is significant. So do not interpret the main effects without considering the interaction. Kuha din sa ordinal interaction, if the lines gani do not cross each other, so wala sila nag-intersect, nor they are parallel, so wala sila sa nag-parallel, o wala sila nag-intersect, mao na gitawag og ordinal interaction. So same ani. So the F-test value for the interaction is significant. And the lines do not cross mao ng ordinal interaction. So the main effects can be interpreted independently to each other. So if there is no significant interaction effect and the lines are parallel, the main effects can be interpreted independently for each other because there is no significant interaction. Nakuha? Kung parallel gani, meaning the main effects can be interpreted independently for each other. So, yung ani siya o forma. Nag-parallel ang lines. Nakuha? So, again, the two-way ANOVA is an extension of the one-way ANOVA. The former can be used to test the effects of two independent variables and the possible interaction effect on a dependent variable. So if an interaction effect is found to be statistically significant, the researcher must investigate further to find out if the main effects can be examined. So that's all for two-way ANOVA, two-way analysis of variance.